Good morning, class. So today we are moving on to chapter 36, which is about motor controls. So I'm gonna go ahead and open up chapter 36. So motor controls. The objectives are explain the difference between light and heavy duty relays, test relays, describe how contactors differ from relays, list the different types of motor protection devices, describe the basic principle of variable frequency drive control. So light and heavy duty relays. Light duty relays, often called pilot duty relays, do not switch motors on or off directly. Instead, they switch large contactors or starters that in turn start and stop motors. In comparison, heavy duty relays can be used to directly turn motors on and off. Heavy duty relays are different than light duty relays in that they do not switch motor contacts and starters on and off, but instead are used to directly start motors. The contacts for a heavy duty relay need to withstand the inrush of current as the motor starts. Test relays. The test coil can be tested by clicking the resistance. By checking the resistance. The coil should be disconnected from the circuit to ensure that you are checking only the coil. Relay coils should have a measurable resistance, not open and not shorted. In the relay coil, I hate not having one with me. I got a contactor, but don't have a relay coil with me. But if you remember how they look on the board, there's a bunch of terminals. The bottom two terminals are the ones that's connected to the coil. So those two are going to be your low voltage circuit. And then all the rest of the terminals on the top, are your high voltage terminals. Contactors. A small motor can be started by simply closing a switch, but a larger motor requires a specialized unit called a motor starter or motor contactor. Relays, contactors, and starters all have contacts that can open and close to complete or disconnect a circuit. Just grab my contactor. One moment. Got my little contactor again. So the surface in here, I don't know, it's still a little hard to see, I guess, but there's the surface down there makes contact with the contacts up here whenever this closes. So see that? Yeah, you can kind of see that happening right there. So the coil is down here, covered in that white insulation, and I'm going to turn that down. All right, there we go. Covered in that white insulation, but all that is a real thin copper wire coiled up, and it's connected on each side to the terminals. One end of the coil is connected to these terminals, the other end is connected to these terminals. And once you get energy there, once the 24-volt signal energizes the coil, then it will then pull those contacts down. You know what? Let me grab a screwdriver. I could possibly make this view a little bit easier to see. Let's grab my screwdriver. We'll pull that screw out so you can get a better look at the contacts really quick. I wasn't prepared to do this. I was just going to move on because I've already shown this contactor a couple times, but whenever it comes up, I just like to make sure it's clear for anyone who missed it before. So since I removed the screws, you got a better view of the contacts. So once this is pulled down, then Then the top portion of the contact will then make contact with the bottom portion of the contact. And what causes that to happen, what causes that to go down is the magnetic field generated by the current to that coil. And the bigger the coil, the stronger the magnetic field. So when we energize that coil, it's going to create a magnetic field, and that's going to pull that closed. And now the power that we have connected to these terminals, right now, they're not, the power won't pass through to these terminals. But once that happens, then whatever power we have hooked up here and here is now allowed to pass over to here and here and complete the circuit all the way to our load, which is our compressor or condenser fan motor or whichever. And now it'll allow it to operate. I just like talking about contactors because it's such a simple concept. And it's like the heart of the system. It's like the main thing. When it comes to air conditioning, when you go out to the condenser, that's all you got out there is a capacitor and a contactor. And in some cases, you'll have more little bells and whistles. If it's a heat pump, you'll have a defrost board, or but for the most part, it's just a capacitor and a contactor. Once it gets the signal from the thermostat, it closes, AC comes on. So contactors, the contacts are rated by the voltage and current they can switch. There are normally 3 current ratings: resistive, FLA, which is full load amps, and LRA, which is lock rotor amps. Starters for motors need to be even larger than simple contactors. Motor protection devices. There are a number of causes for motor failure. The most common problem is excessive heating. Among the causes of excessive heating are the following: defective start relay and excessive load. So excessive load is like probably even more common than the first one. Motor protection devices. Loss of refrigerant on a gas-cooled motor, excessive time on locked rotor current, operation at too high or too low voltage, single phasing on a 3-phase motor. All motor protected devices are designed to cut off the power to the motor before damage has occurred. So basically, if any of these conditions occur, the motor is supposed to be turned off by a safety mechanism of some sort to prevent damage. Motor protection devices. Repeated cycling on the protective device can damage a motor. There are 3 types of protective devices that are used to protect the motor against excessive heat: temperature actuated, current actuated, combination of current and temperature. So basically, there'll be a sensor somewhere saying, hey, it's getting too hot, let's turn this motor off. Or there'll be the current one, where basically if too much current is allowed to go through, it'll open up the switch and cut the system off. Variable frequency drive control. There are many applications where variable fan or compressor speed can improve the operation of and efficiency of a HVAC system or HVAC unit. So for many of these applications, DC motors can provide for a wide range of speed control. Variable frequency drive control, pulse wave modulation, intelligent power module, super power protection, supply power protection. Yeah, just bear with me today. I don't know where I left my brain, but I'm working on it. Filters and noise. So VFDs, or variable frequency drives, are there to do just that. It's to be able to vary the speed on your motors, so that you don't have to have them at 100% all the time. Because when a motor is just full speed all the time or off and no in between, then it's using up, you're wasting a lot of energy with that, because the load changes. So when loads change, what is a load? The load is the heat on your evap coil. So let's say right now I'm alone in this room. So there's not a very large load on my evap coil. If I were to turn the AC on, it wouldn't take very much time to cool this room down, and there wouldn't be a very large load. It's just me and a tiny little dog. So if I were to call, all my friends and say, hey, social distancing is over, everybody come through, we turning up, and all of a sudden I had, 20 people in here, that's an increased load. So right now, if the system was on, if I had a modulating system or variable frequency drive connected to it, it would bring my fan speed down a notch and my compressor speed down a notch, because it's only me in here. And then once everybody gets here and we're doing our thing, it's going to kick everything into full speed or high speed, because now we need to be at full capacity because we have a higher load on the system. So variable frequency drives are installed in a lot of commercial applications to give the systems that ability so that they can save the company on operating costs. So in summary, relays are used in motor control circuits to either start a motor directly or indirectly through a motor controller or starter. Light duty relays are generally used in combination with motor controllers and starters to indirectly start a motor. Motor protection controls are required in addition to motor controls for starting. Relays can be used in combination to stop, start, and engage safety cutouts. The most common cause of motor failure is from overheating, which can be attributed to a number of operating conditions, including excessive load, single phasing, and operation at too high or too low of voltage. So that is it for unit 36. Hopefully that was helpful. Read your book, especially right now when we don't have a lot of time to interact. Make sure you're reading that book, spend a lot of time on that, just so you can get a clear understanding of what's being taught. So when you go over your review questions and you're reading through the chapter, trying to figure out, where the answers are, after you complete the assignment and you put you got the right answers, I'm the type, I still like to make sure I go back and understand what I just learned, whatever they just told me. Like, okay, so this matched that. Okay, you can put the words together and get the correct answer for the question and be done with it without actually grasping the concept. So I like to not just put my answer down, but try to understand it. Maybe even try to put it in terms that relate to real life, which I know in some cases can be hard because a lot of you haven't been out there face to face with some of these pieces of equipment yet. So I get it, but just read and retain as much as you can. Stay home, stay safe, stay healthy, and I will see y'all next time. All right.